Hi, in this lesson we are going to learn about function notation. And at first it's going to feel kind of strange, and that's normal, but you'll see that once you accept it or learn it, it's actually quite handy and provides greater clarification in math. So, for example, we just got done looking at parabolas. So, for example, say we had y equals x squared. And maybe we had another parabola like y equals x squared minus 4x plus 3. Now, if I said evaluate when x equals 3, I can do that. And from the first problem, and I'm going to use an arrow here. So for the first problem, I would go y equals 3 squared and come up with 9. And then in the second one, I would do the same thing. I would take 3 squared minus 4 times 3 plus a 3. So it's 9 minus 12 is negative 3 plus a 3, and I got 0. So if I just wrote my answers as y equals 9 and y equals 0, well, you have no idea where the 0 or the 9 came from. All you know is, so what we do is this instead. And I could have done this. So I could have given you two equations, written one as y equals x squared, and then I could have given you a red equation and made the second equation in red x squared minus 4x plus 3. And then if I recorded my answers as a blue answer, if I recorded one answer as blue and the other answer in red, you would know which equation that y value came from when, in fact, we looked at just the simple case of when x was 3. But most of our mathematicians, they don't do their work in colors, they do their work in pencil, or sometimes some brave mathematicians use pen, but most of us use pencil. So what we do instead is, instead of using blue and red, but to provide clarity, we might say this first equation here is, we'll call it f of x. And the second one, we'll call it g of x. So really, we're calling the first one f and the second one g. It's no different than thinking of all of us as people, but to differentiate the people, we give them different names. And so the first one, we're just calling it f, and the second one, we're calling it g. The of x, this part, just tells what the variable is. Variable is. So in this case, it's x, and you could have a function in y. That would be okay too. So let's try this. And I'm going to do the same problem, but use my function notation. So if I talk about f, and I want to know what f is when x is 3, then I would substitute the 3 in place of the x. And so I would know that f, you could say it this way, that f evaluated at 3 equals 9. And if I use the second problem, I wouldn't use f. Now I call it g, and I might want to evaluate it when x is 3. So then I would go through the exact same process that we did up above. I would take my 3, square it, minus 4 times 3 plus a 3, and I would know that when x is 3 in g, the result is 0. And so that's why we use the function notation. It tells us which function we're talking about and where we're evaluating the function. So let's try a few examples. Suppose I have three functions. We'll call one of them, this is a new f, we're going to call f of x. This equals x squared plus x minus 4. We have another one, we'll call it g of x. And we'll give it the square root of x. And finally, we'll do one more, h of x, and that is x squared minus 4. So let's try this. Let's find a couple different examples. For example, if I asked you what g of 25 is, well, you would say, you'd refer to g and say, I replace the x with a 25. Oh, and I know that the square root of 25 is 5. Then let's take a look at another one. Let's try h when x is -1. Well, then I would plug -1 and square it, minus 4. Well, -1 squared is 1 minus 4, so h of -1 is -3. Or you could also write it down here, -3, and carry your work down. Either is acceptable. Let's try another. How about f of -1/2? Here's a tough one. So let's try it though. So this says, we refer back to our f. So this says we take -1/2, square it, plus another -1/2, and then we're going to subtract 4. This time I'll bring my notation down. So this is -1/2 squared becomes 1/4, minus 1/2, minus 4. I'm going to need a common denominator, and in this case I think my lowest common denominator is 4. So my first fraction has the lowest common denominator. The -1/2 becomes -2/4, and -4 becomes -16/4. So if we add these up, I have 1 minus 2, that's -1, minus 16 more to come up with f of -1/2 equals -17/4. And let's try one more. Let's try g of 0. Well, we can do that. That's the square root of 0, and we know that 0 squared is 0, so the square root of 0 is 0. And that's how you use function notation to differentiate which function you're talking about, and to also keep track of what your answer is when you're evaluating that specific function. Thanks for watching.